Hi, and welcome to this section of the Advanced Calculus 2 tutor. And in this section, we're going to cover the topic of arc lengths in parametric coordinates, or in parametric equations, okay? So let's stop and think about where we've been and where we're going, because it helps to get the big picture. A few sections ago, we talked about the topic of arc length, which was just telling you how to integrate, okay? All right, now what we want to do is we want to find an equivalent expression, okay, when the function is not given in terms of f of x, it's given in terms of x of t and y of t. Or it could be any variable here, but we usually call t. So what we're going to have is, draw a little picture, okay? What we're going to have is, we're going to have some function. Let's say it goes up like this and it goes down, whatever this function looks like, okay? This is x and this is y. And if this function were f of x and defined in terms of an f of x, we would simply put it in here and get the answer. But let's say this function is not defined in terms of f of x. It has x of t defining the x coordinate and y of t defining the y coordinate, just as we talked in the last section on parametric equations, okay? So we want to find the arc length, okay? So what we're going to do is we're going to do something very similar to what we did before when we derived the arc length the first place. We're going to look at 2 points, okay? And this point is going to be called P, and I'm going to call him P sub I just because he's the ith point. The length is going to be the integral from 0 to 2, because that's alpha and beta, okay, of dx dt squared, which is 100, well actually it's the square root of 100t squared plus 36t squared, because that's dy dt squared, and we're integrating over dt, okay? Now you have 100t squared plus 36t squared, so you can add those up. 0 to 2, square root of 136t squared dt. Okay, now, and you crank through the integral. Usually you'll get some kind of nice simplification under that radical, so you can take the square root of it and make it integrable, and without too many sessions of banging your head against the wall. And that's how you tackle arc length in parametric equations.